AP Review 9 is dealing with balancing equations. We did quite a lot of this in Chem 1. So you see here methane and 2 oxygens makes a CO2 and 2 H2Os. Conservation of mass is obtained. 1 carbon, 4 oxygens, 4 hydrogens are present on both sides of the equation. Reactants on the left, products on the right. So when you're balancing equations, you always want to make sure you count up the atoms of each element on both sides of the arrow. I always recommend you start with the more unique elements first. Like magnesium, chromium, things like that. We do not change the chemical formulas. We do not change the subscripts. We can change the coefficients, how many of each one we have to make a balanced equation. Hydrogen and oxygen are the culprits that usually can cause the most issues, so I tend to wait on those, along with anything else that you see in more than one reactant or more than one product. And then if you see a polyatomic, a group of atoms that are found on both the reactant side as well as the product side, you can treat them individually or you can treat them as a single unit. So in this particular example, we see KClO3 decomposing. This is used to provide oxygen sources for combusting any sort of carbon-based object, inanimate, like sugar cubes, pencils, gummy bears, things along those lines. We see that the potassium is balanced at first, 1 atom of each on both sides. Same for the chlorine. We see the oxygens are different. 3 oxygens on the reactant side, 2 on the products. So we want to find the next common factor that they have, which would be 6, which means I would need to increase the oxygen on the right by 3. So 3 times 2 would give me 6. And I would need to increase this one by 2. 2 times 3 would give me 6. When I do that, that increases my K and my Cl. I have 2 now of each of those, so I would need to double the K and Cl for this equation to be completely balanced. In the second example here, we have lead 4 nitrate and calcium sulfate making lead 4 sulfate and calcium nitrate. There's a lot of polyatomics, a lot of parentheses, a lot of little numbers. Don't let those stress you out. Again, I usually start from left to right. Looking for unique elements. PB is pretty unique. There's only 1 on both sides of the equation, so that's balanced. Now I'm going to look at this whole NO3 object, because I see that there's an NO3 over here as well. If you don't like that, you could just focus on nitrogen. Regardless, there's 4 of the nitrogens or 4 of the NO3s on this side of the equation, on your reactant side, but there's only 2 on the product side. So right there, that tells me I need to increase the number on the product side by 2. Now when I do that, that increases my calcium. If you had chosen to wait on oxygen and treat everything individually, oxygen's in all 4 of these compounds. We are not going to want to go anywhere near oxygen until we're at the very end of the balancing. So I'm going to go ahead and take care of calcium. There's 2 here on the product side. There's only 1 on the reactant side, so I would need to double that as well. And that gives me 2 of these SO4s. Well, over here I have 2 of the SO4s, so that would balance out my sulfates. Again, if you did want to do this by individual atoms, if we look at oxygen here, 3 times 4, we always multiply within a formula. So 3 times 4 would give me 12 oxygens. 2 times 4 would give me 8 oxygens, and then because there's a plus between them, I would add. So 12 plus 8 would give me 20 oxygens. Over here I see 4 times 2, that would give me 8. 3 times 2, which is 6, times another 2, which would give me 12. So I have 12 oxygens and the 2 calcium nitrates, 8 and the 1 lead 4 sulfate. 8 plus 12 would give me 20, which balances out with my reactant side. And then the final one I was going to review with you is a combustion. C3H6 plus oxygen makes CO2 and H2O. With this one, I would go ahead and start with my carbons. I have 3 on the reactant side, so I need 3 on the product side. I have 6 hydrogens on the reactant side, so I need 6 hydrogens on the product side. 3 times 2 would give me 6. And now I need to deal with the oxygens. I have 6 oxygens here in the 3 times 2, the 3 CO2s, and I have 3 oxygens here in the 3 H2Os. 6 plus 3 would give me 9 oxygens. What times 2 would give me 9 oxygens? Well, 4.5 or 9 halves. But we don't get to use fractions as our coefficients. So you may remember this from the first time you took chemistry, how we need to go back through and double all of our coefficients so that they are whole numbers. You always want to use the simplest whole number ratios you can, but you do need to use whole number ratios. So the 1 that was in front of C3H6 would become a 2. The 9 halves times 2 would become 9. 3 times 2 would become 6. And 3 times 2 would become 6. So now I have 6 carbons, 12 hydrogens, 12 hydrogens, 18 oxygens. 6 times 2 is 12. Plus another 6 would give me the 18 oxygens. So at this point you should be able to do question 23, the 4 balancing equations that are on your summer assignment.